Following Argand diagram shows a circle centered 0 and a radius of 4 units. Then they have mentioned that the set of points on this plane, basically on this curve, on the circle, are defined by this equation. Question is, plot on this diagram the points corresponding to different angles, different thetas, right? So step one is to analyze the equation, and you need to check which equation, rather which form does this equation look like. So remember, there are three types of representation of complex numbers. First is called the Cartesian form. Let me just write it down. So the Cartesian form looks like a plus ib. Z is equal to a plus ib is the Cartesian form. Then we have the same complex number can be represented in the polar form, the polar argument modulus form. It's written like this: mod z cos theta plus I sin theta. That's the second form. And the third form is the Euler's form, often called the Euler's form. So z is equal to mod z e to the power I theta. So now if you analyze the given equation with the three forms, you can easily identify that the equation is the Euler's form, right? So let's compare the given equation with the Euler's form. So if you compare the two equations, you will see that this term theta by 2 is the mod z. Mod is the magnitude of that complex number, and e to the power I theta, where theta stands for the argument, right? And then we have to plot different points. Now, to go ahead and plotting the points, let's understand the definition of argument again. So have a look at this diagram. If you have a complex number z, which is in this form, a plus ib, a is the real part and b is the imaginary part. So the angle which the complex number makes with the positive real axis is called the argument. So this particular angle theta is the argument, right? Now let's analyze. Part 1, theta is equal to pi by 2. So if you put pi by 2 in this particular equation, let's see what do we get. So the equation becomes z equals to pi by 4. Why pi by 4? Because it is theta by 2. So pi by 2 divided by 2 will give you pi by 4. And in front of it, we write down the argument. So e to the power of pi by 2 I. Now you just remember that whatever comes in front of e is the mod. So this is your mod z. And the argument in this case is pi by 2. So now what you need to do is draw a line of length pi by 4, which is at an angle of pi by 2 from the positive real axis. So before I draw here, let me try to make a rough diagram on the right hand side. So analyze. We have to draw a line segment which is having a length of pi by 4, which is at an angle of pi by 2 with the positive real axis. So let me change the color. If I draw a line segment like this, it is at an angle of 90 degrees or pi by 2 from the positive real axis, and in such a way that the length of this line segment, which is called the mod, should be equal to pi by 4. Now, this is what we need to do in the diagram on the left hand side. We need pi by 4 as the length. So observe pi by 2 is already plotted here. So the half of that will be pi by 4. So let's plot a point here. And then if I draw a line segment starting from the origin and going upwards, we have to plot the point. So the point is over here. And let us write down the coordinate anyways, or it's not required. So x coordinate is 0 and the y coordinate is pi by 4. Bear in mind, these are not x and y coordinates. It's the real coordinate and the imaginary coordinate. So real coordinate is 0 and the imaginary coordinate is pi by 4 for this particular point. So the location of this point is the answer for the first part, theta as pi by 2. Now, similarly, let's apply the same logic for the second case when theta is pi. So, okay, let me delete this. All right, so when theta is equal to pi and apply the same equation as in which is given. So Z in the second case will be pi by 2. into e to the power I pi. All we have done is put theta is equal to pi in the given equation, and then you compare it with the standard Euler's form. So pi by 2 will be the mod z, which is the length of that complex number, and the argument in this case will be pi. So let's go back in this Argand diagram. You have to draw a length of pi by 2, which should be at an angle of pi or 180 degrees from the positive real axis. So again, let me draw a rough diagram. I'll draw the real axis and the imaginary axis. Remember, we need an angle of 180 degrees from the positive real axis. So if I draw a line segment like this, such that the angle is 180 degrees or pi radians, and the length has to be equal to pi by 2. Why pi by 2? Because that's the mod z, that's the magnitude, right? So if you draw that in the same diagram, let's plot the point. So the point will be over here. So watch this particular point and let's check what's the coordinates. So the real coordinate of this complex number will be minus pi by 2. Imaginary part is 0. So this is the answer for the second case. Third case, theta is equal to 3 pi by 2. So let's apply the same logic. Third case. So if we put theta is equal to 3 pi by 2 in the original equation, the z will come out as 3 pi by 4 into e to the power 3 pi by 2 multiplied by I. And then again, like always, we compare it with the standard form. 3 pi by 4 will be the mod z, and 3 pi by 2 is your argument. 3 pi by 2 is 270 degrees, which means now we need to draw a line segment which is at an angle of 270 degrees from the real axis. But remember, whenever we are dealing with angles, the angles are going in anti-clockwise direction. So we go 270 degrees in the anti-clockwise direction to get the complex number. And the length of this complex number has to be 3 pi by 4. So let's plot that in the original Argand diagram. 3 pi by 4 will be somewhere over here. See, 3 pi by 2 is already given. So if you half it, 3 pi by 4 will be over here. So this is the point. And the coordinate will be, so the real part, of course, is 0, and the imaginary part is negative 3 pi by 4. Bear in mind, these points, these coordinates are not required. Just the plotting of the point will be the answer to these questions, A, 1, 2, and 3. Moving ahead to the B part of the question. So it's the main data is still the same. The B part is find this value of theta. So this one is a little tricky because the equation is only one. Z is equal to theta by 2, e to the power I theta. We saw this is the Euler's form. And remember, whatever comes in front of e, this is your modulus, mod z. So let me write mod z is equal to theta by 2. Now, this entire equation basically represents all the points on this circle. So if you randomly take any point on this circle, let me put a cross. So the distance of that complex number from the origin by definition is the mod z, right? So mod z also is equal to the radius of this circle, which is equal to 4 units. And that's why we can write mod z is equal to 4 units. So you equate theta by 2 with 4 to get 8. 8 will be the answer for the first case. So let us repeat. Mod z is the distance of the complex number from the origin, which in this case is the radius of the circle, equals to 4 units. Also, the same mod z, by comparing it with the same Euler's form, mod z is equal to theta by 2. So that's why we did theta by 2 is equal to 4. Second part is for this value of theta, which is 8, plot the Argand position of the complex number on this Argand diagram. So how do we do that? So we go back to the Euler's form. Remember, so let's write down z is equal to mod z e to the power I theta. Your theta value is equal to 8. So if you put that in the equation, the modulus will become 4. So your z will become z is equal to 4 e to the power I 8. Right now, observe 8 is the argument here. Theta is equal to 8. So what we need to do, you need to just draw complex number which should have a length of 4, but it should have an angle of 8 degrees from the positive real axis. Now, this one is a little tricky because the argument, okay, see, the basics of argument is the angle should satisfy, or rather, it should fall in this particular range, minus pi to pi. But let's see, it does 8 even fall in that particular category? Pi, see, remember the value of pi. Pi is 3.14 radians. So the value of theta needs to fall in this particular range, then it's considered as the argument. In this case, the theta is 8, which is much beyond 3.14. So how do we find the correct argument? So the steps involved are, let me write on the step. All you need to do is subtract 2 pi from whatever argument which is given to you. In this case, the value of theta is 8. So what we will do, we will take the original argument theta and subtract 2 pi from it. And let's see what do we get. If you do 8 minus 2 pi, this will be 8 minus 2 into 3.14. This comes out as 1.72 radians. Now, this value definitely falls under this range. So what we need to do is, let's draw a rough diagram. So we don't know as of yet 1.72 means which quadrant. So randomly as of now, let's say it is the first quadrant, hypothetically. So your complex number should have a length of 4 units at an angle of 1.72 radians. But we need to be careful. 1.72 radians, will it be in the first quadrant or the second quadrant or third or fourth? So how do we check that? So to check it, what we need to do, let's draw another Argand diagram. So the angle starts from here. It is 0 degrees. So we go from 0 degrees all the way till pi by 2. Let's make the complete diagram. Pi by 2, 2 pi, and one more rotation, 3 pi by 2. And then if you do one more rotation, we come back to 2 pi. So 0 and 2 pi are basically the same. And that is the reason we were subtracting 2 pi. So 2 pi is basically one rotation. So either we can subtract or even if you can add 2 pi such that the theta value should fall under this range. Now, the argument which we have found is 1.72. Now let us check out the value of rather the value of pi by 2. See, pi, remember, is 3.14. So the value which we need is 1.72, which means clearly that this 1.72 has to lie between 0 and 3.14. So somewhere in the first or the second quadrant. But to be more specific, we need to accurately identify the value of pi by 2. So we do 3.14 divided by 2, which is equal to 1.57. Let me write it down, 1.57. Now back to the original argument, we need 1.72. So from 0, we have already reached the 1.57. Since your answer is 1.72, which means the complex number will be somewhere in the second quadrant. So we want to just go a little bit ahead. See, 1.57 is already the y-axis. We need to go a little ahead so that the angle is 1.72. So let's draw a rough diagram. So we will draw a complex number which will have a length of 4 units such that the total angle with the positive real axis is 1.72 radians. So this is the rough diagram. Now, if we go back into the original diagram, remember, the complex number which we have found is in the second quadrant, right? So the length is 4 and the angle is 1.72 radians. The value 4 and 1.72 is not required, just the position of the point. So the answer to this question is basically, if I put a cross here, that's the answer to the B part, the second part. Second coordinate, and the distance from the origin is 4 units.